All right, well, good morning, good afternoon, good evening. Welcome to 5.6. Shoot, this should be C. Sorry, 5.6 C. We're going to call it polynomials multiplication, and it's going to be perfect square trinomials. Kind of a different, specific application again, similar to difference of squares, but it's going to be a specific application to a specific situation where we're multiplying binomials times binomials. Let's take a look at this. We're going to get to this in the next section, but right now we're going to talk about perfect square trinomials. We're going to find out what the perfect square trinomial kind of looks like. So let's fast forward through all the stuff that we've taken care of. Again, all that stuff is kind of refresher of our memories. Here's a situation that we've got for perfect square trinomials. We're going to talk about perfect square trinomials. And if we square a binomial, let's take a look at what we get. We get a special pattern. Let's find out how we get that. If I've got something like 3x plus 7, there's my polynomial, but it's a binomial. If I take that polynomial, and I square it, what do I get? Well, here's the long way to go. 3x plus 7, because what this is, here's again my base, 3x plus 7, squared, and that squared works on the entire base, so I've got to square that entire base. So that means that means that it's the base times the base. So here's my base, and I've got now in the longhand 3x plus 7 times 3x plus 7. So there's my binomial times a binomial. There's my base times the base. And now what we can do is we can FOIL. We can use that dreaded F word in math, the FOIL. First, outside, inside, last. What's the first terms times the first terms? 3x times 3x gives me 9x squared. Outside terms is 3x times 7 gives me plus 21x. Inside terms, 7 plus 7 times plus 3 gives me plus 21x. Last terms, 7 times 7 plus 49. Plus 7 times plus 7 plus 49. Alright, so there's our FOILed multiplication. What do? We're going to combine these like terms. Plus 21x gives us plus 42x. These two are like terms because it's exactly the same variable to the exactly the same power. Plus 21 gives me plus 42x. And right there is our kind of answer. And we're going to kind of analyze that answer and see what kind of pattern we can come up with. This, again, kind of like the difference of squares, this first term is the first term, a term, squared. 3x squared is 9x squared. The last term is the last term in our binomial squared. 7 squared is 49. 7 squared is 49. 3x squared is 9x squared. This middle term is kind of where it comes, you got to pay a little bit of attention. What it is 2 times the first term times the second term. Here's our first term in our binomial that we're multiplying, that we're squaring. Here's our second term. So first term times the second term times 2, first term times second term times 2 is this one here. 2 times 3 is 6, times 7 is 42, 42x. So there is the important thing there. We got a 2ab. So if I had to kind of write this out, I would say this would be my a. I guess if we're going back up here, this would be my maybe a plus b quantity squared. Here's my a term. There's my b term. Here then would be my a squared. This would be my b squared, and this would be 2 times a times b, because here's my a term, 3x. A term is 3x. B term is 7. B term is 7. So the pattern then becomes a plus b squared gives me a squared plus 2ab plus b squared. And in fact here, right down here, is what we just did right there. A plus b quantity squared. Here's my a plus b. Here's my a term. There's my b term. What it becomes is a squared plus 2ab plus b squared, which is in fact right there. A squared plus 2ab plus b squared. Now the funny thing is, if the only difference is if you've got a minus term, a minus b quantity squared, again a perfect square trinomial, you get the pattern of a squared minus 2ab plus b squared. And that's the only difference. So there's the pattern. If you want to use that pattern, you can go ahead and do that. If you don't want to use the pattern and say, oh, I know it's, this binomial squared gives me a squared plus 2ab plus b squared. Some people don't recognize that. If you don't, then just go ahead and FOIL it out. Start here, and then just keep going down here with first, outside, inside, last, and get to here, combine the like terms, and you should get to there. So if you recognize it though, it's kind of a shortcut. So there's a difference of squares that we did last video. Here's a perfect square trinomial pattern that we recognize this time. So let's go through a couple of examples and say, now with this in mind, all of this, with that in mind, figure out whether on the next page we have either a difference of squares or a perfect square trinomial, and see if you can use the pattern here. A plus b times a minus b gives us a squared minus b squared. And the second pattern is the perfect square trinomial. A plus b quantity squared is this. A minus b quantity squared is this. A squared minus 2ab, a squared plus 2ab. See if you can use the pattern. First, I guess the first question is recognize what you have. So let's go through. I'm going to ask you to pause the video. Go through and say, is this a perfect square trinomial or is this a difference of squares? So let's pause the video, go through it, and say this is a difference of squares or perfect square. Alright, so this one should be I've got an a term, I've got a b term, that's exactly the same, but this is subtraction, this is addition, this should be a difference of squares. Let's see, I've got an a term, 1/2 p, and 1/2 p is exactly the same. I've got a 6 and I've got a 6. I've got a difference here and an addition here. This would be the difference of squares. Let's see, this one down here, a little bit trickier. This is a 3w. Here's an a, here's a b term. And all we have to do is recognize that this is shorthand for 3w minus 4 times 3w minus 4, and that should be a perfect square. This is, well, the same thing. This should be the longhand. It'd be 5x squared plus 2 times 5x squared plus 2, because that squared makes us write this base twice multiplied by itself. So here again is a perfect square. We should recognize it because here we've got plus and plus, here we've got minus and minus. They're the same. If one was a minus and one was a plus, we'd have a difference of squares. If one was a minus, one was a plus, we'd have a difference of squares. But we don't. We've got a plus and a plus. That means it's a perfect square. So now I'm going to ask you, now that we know that this is a difference of squares, this is a difference of squares, here's a perfect square, here's a perfect square. Now that we know that, let's go through and see if we can use the pattern that we know from the previous video as well as this video and define our difference of squares answer for these two and perfect square answer for these two. Now if you need to go through the FOIL here, you can go ahead and do that. Try to use the pattern though. If you need to, you can go back and use the formula that we learned, and we'll see what we can do. Alright, so first one, I'm going to say this is the difference of squares. If this is my a and b term and a and b term, then the difference of squares says that, well, I've got a squared minus b squared is my answer. So my a term is x, so that should be x squared minus, what's my b term? B is 9 squared, and there's a difference between them because we get difference of squares. This is a difference of squares pattern. So my answer officially should be x squared minus 81. There's the answer. This one as well, a difference of squares. We said it was a difference of squares, so we should say, here's my, again, a squared minus b squared should be my answer. What's my a term? Here's my a term, here's my b term. B term is 6, a is 1/2 p. So my a squared term should be 1/2 p, and the whole thing is squared because my a is 1/2 p, a is 1/2 p, and we got to square it. Minus my b term is 6 squared. So now we have to multiply 1/2 p times 1/2 p to get 1/4 p squared minus 36, and that should be our answer. Alright, let's go down here and say, what about these? These are, again, perfect square trinomials. So if we've got an a term here, whoops, how did I get yellow? If I have an a term here, let's see if it turns to green, thank you. a term here and a b term here. My a term is 3w and my b term is 4. So again, my pattern for the perfect square trinomial answer should be a squared. This is subtraction, so it's subtraction, minus 2ab plus b squared. And again, my a term is 3w, so I have to substitute 3w in here. And the whole thing of 3w has to be squared. Minus 2 times a is 3w, b is 4, plus b squared, b is 4 squared. It's kind of the longhand, but now we just kind of go through it and square everything. 3w squared is 9w squared, minus 2 times 3 times 4 is 12 times 2 is 24, w plus 16, and that should be our answer. Alright, last one here. Alright, well here's where you guys get to do the perfect square itself. So you guys do this as your homework. Again, take your notes for the whole video, take a picture of your notes, solve in your notes this homework question, and give me an answer in terms of the perfect square trinomial. Alright, any questions, let me know.